Hi, this is Mr. Adams from Midwood High School, and this is a brief video on redox reactions. Once again, as a reminder, we know that if something is oxidized or undergoes oxidation, it's doing LEO and it loses electrons. When something loses the electrons don't go into outer space, something else will get reduced, something else will undergo GER. Okay, so you can be given an equation like this one right here, right? And you can be asked which substance was oxidized, okay, and which substance was reduced. You can be also asked about the agents, all right? So we're going to go over that right now. Okay, the substance oxidized will always go up in oxidation number because it's losing negative and becoming more positive. The substance reduced will have a reduction in its oxidation number, okay, hence the name, reduction, because it's gaining negative and becoming more negative as oxidation number goes down. In terms of agents, we did this already in class, you think opposites, right? If something is going to be oxidized, okay, if something's oxidized, it will be the reducing agent. And opposites again, if something's reduced, it will be the oxidizing agent. And a nice memory device right here, the guy that's oxidized, the guy that undergoes GER in terms of gaining electrons, and the agents, they will all be found on the reactant side. Okay, on the reactant side. A bit of a typo there, no problem. All right, and as a reminder also, double replacement reactions will be never redox. So if you encounter a double replacement reaction, okay, you don't even have to put the oxidation numbers in. Okay, you know automatically that guy will not be redox. For example, neutralization reactions. All right, we have a equation in the bottom here. As always, you're going to pause the video and do this one. What you're going to do is you're going to put the oxidation numbers in. You're going to tell which substance was oxidized, which substance was reduced, along with the oxidizing and reducing agents. We have another example over here. You're going to put the numbers in and tell which is oxidized, reduced, and the agents. Okay. All right. We have this equation, carbon dioxide reacting with hydrogen gas to produce carbon monoxide and water. All right, so as we always said, right, oxygen most of the time has a -2 or -2 oxidation state, and we have two of them right here, right? So 2 times -2 will give us -4. So in this case right here, carbon and carbon dioxide has a +4 oxidation state, okay? Now, once again, you should do these things with your rules, right? And these rules will eventually stick on your fingertips. Now, we have here the element hydrogen, and it's by itself, so the oxidation number will be what? It will be 0, because it's unattached, it's free, it's uncombined. So the oxidation number is 0. Moving on to the product side, we have carbon monoxide right here. We know that oxygen, once again, most of the time is going to be -2 again. Okay, in this case, carbon will be +2. How do we know? Because carbon monoxide is a neutral compound. Everything has to add up to 0. So if oxygen is -2, the carbon must be +2. Okay. And in water, once again, oxygen is going to be -2. And hydrogen, most of the time we know, is +1. Okay, so what they can ask folks simply is who got oxidized, who got reduced. So if we look at this equation carefully, we see that oxygen is going from 0, okay, it's going from 0 here to a value of +1. Now, if you're going from 0 to +1, your oxidation number is increasing. So if your oxidation number is going up, you know this guy right here on the reactant side was oxidized. He lost electrons and became more positive. You're done. Okay. And we notice also on the flip side of that, that carbon, okay, is going from +4 to +2. Okay, so if you're going from +4 to +2, your oxidation number is going down. Okay, so we can say that carbon in CO2 is being reduced because the number went from 4 to 2. All right, now in terms of agents, right, we just do the flip. All right, the flip side of it. We know that this guy right here, right, he got oxidized, therefore he will be the reducing agent. You just turn it around, use opposites. We know that carbon, okay, carbon went from +4 to +2, so carbon's guy right here, okay, +4, he was reduced, all right, therefore he will be the oxidizing agent, okay, and you're done, all right, so that's who got oxidized, who got reduced, and the agents in a nutshell. All right, this equation right here, we're going to do this one again, all right. Na is by itself, so its oxidation number will be 0. Okay, hydrogen most of the time will be +1. Oxygen will be -2. Na is +1. Okay, oxygen most of the time is -2. Hydrogen will be +1 here. Okay, and hydrogen by itself over here will be 0. Okay, so what you can be asked again, who got reduced, who got oxidized. So we look at it carefully. We see that Na went from 0, right, to +1. So Na solid, okay, Na solid was oxidized, all right? So because his number went up. So he was oxidized. And based on that, you can also say, since he was oxidized, he will be what agent? Yes, he will be the reducing agent. All right, and you look carefully again, we see that hydrogen went from +1, okay, +1 to 0. So if you go from +1 to 0, you're being reduced. Okay, so we say H2, okay, was reduced. Now notice the Na solid and the H2, they're both on what side? They're both on the reactant side. So H2 was reduced, okay? And what kind of agent will he be? Yes, he would be a oxidizing agent, okay? All right, and you're done. All right, so this is a very, very brief video. Okay, we got 2 examples right here of how do you figure out who got oxidized, who got reduced, and the agents. As always, hard work plus sacrifice equals success, and you can't be studying. Once again, these videos are just a guide and a supplement. They're not meant to replace you actually studying, folks. Okay, I'm having a bit of a problem with that. So please study, and take care.